Hi, today the main topic is the Bayes scheduling algorithm. First of all, why do we need to have why do we have to make a scheduling algorithm? Um, the, the the scheduling algorithm is really being widely used. Example, if you're a front-end engineer, there's the React scheduling algorithm that they consider which task has to be rendered or renders some kind of specific UI. Even if those kind of scheduling thing is using in the React, and also even operating system or whatever thing, even load balancer using this schedule algorithm. But first of all, let's try to utilize the operating system concept to explain scheduling algorithm. First of all, if inside the operating system, there's a process. What is process? The process, the meaning is, it is the running instance of program. But the question is, what's the meaning of the instance? And what's the program? Program is just a bunch of instruction that tells the computer what to do. So program, what I believe is just kind of static, but a bunch of instructions of it. And when it's gonna be running, and the meaning of the instance is it is like some kind of copy of original version, but the copied version still belongs to the original version. Example, there's a class car, and you extend this class car because there's a method that drive and stop, and there's a class Hyundai car extends car, and this extends, or this kind of thing, is also called the instance of the original class. And this kind of example of use explain instance of it. And process is running instance of the program. And what is instructions in program? The instructions, what I believe is just the assembly code, and that's what to do. Example, there's a move. It was like A1, it was like S1, whatever stuff, and you can just put value on here. I think it was like register. It was not register here, but I'm not sure because I only have really small experience of using assembly language. And if you look at it, it's just like they move or do whatever stuff. But sadly, actually our computer cannot read this instruction at the same time. What the meaning of the concurrency in the computer science world isn't really different in the real world. Example, there's a line of it. If you have experience of watching some kind of F1 car race, the car seems like they're entering the same time. If you look at it closely, there's gonna be some kind of mistake of it. There's some kind of really difference of it, even though really milliseconds. So there's no doing at the same time in this world. And the computer science, what I believe is, even in the computer science world, there's no doing at the same time at the exactly milliseconds. And when it's gonna be running, there's a process of it. So there you cannot redo the process at almost at the same time. And there's a process. So you can just you can't do it, but there's a bunch of process, and you have to decide which task or which process has to be done faster and quickly. That's kind of really the thing of the scheduling algorithm. Example, you are in the some kind of window operating system. You click the folder, but you click the folder, you instantly you click some kind of application of it. But since you already clicked the folder, the application got postponed, or if you just click application a lot of times, these applications opened, and some kind of it blocks other application, and those kind of thing, and those kind of thing is kind of really bad. It's kind of example of there is no scheduling thing. If there is no scheduling thing, there's gonna be bad user experience. It's gonna be bad for the user to use this kind of product because operating system, because basically we want to make some kind of smooth experience. Example, if we trying to switch application, it has to be smooth because the application has their own process, and the process has to be scheduled by the based on the users behavior or users behavior, because the process, because there's a lot of process in the operating system, and scheduler thing is the one who handles this kind of process. It's just like it just like, yeah, you can just use the really meaning of the scheduling. Their scheduling is basically it schedules your process. But there's a three basic process in this scheduling algorithm. There's a more scheduling algorithm, example MLFQ, multi-feedback queue, but there's other scheduling algorithm. But basically they're using, their foundation is using the basic scheduling algorithm. So it's better to understand this first and go to the next topic. So the first is FCFS, first come first serve. It's simple. Whatever the process goes with it, whatever the time of it, the first one, first come first serve. Think about just the queue data structure of it. And that's really simple, but that's gonna be issue, because what if there's a longer task here, and the longer task here, and this longer task has to be first keeps on waiting till the other process to be executed. So the problem of the FCFS scheduling is called the starvation issue. And also there's no kind of there's no, how to say it, there's no order or anything. And the next thing is the second base algorithm, the schedule algorithm, is called the SJF. Shortest job first. Shortest job first, yeah, it just basically means that shortest job doing first. The meaning of the shortest job is the burst time of the burst. Basically, the meaning is the short burst time. The burst time is example, this some kind of process is executed faster than the other process, because the CPU is basically doing execution part, reading as execution, and based on the burst time, which is those kind of the time to the CPU do the task of the whatever process, and that's called the burst time. And based on the burst time, if this job is short, it goes to front, and that's it. Example, P2, P3, P4, P5, P6. Based on the burst time, the process comes to front. If there's longer, it goes to backward. And those kind of thing can also lead to the problem, but there's ordering, but there's the starvation problem, because this longer process could be the process has to be doing it immediately, and that's gonna be a problem with it. The next thing is round robin. Round robin, you might think round robin is a really kind of hard task, really some kind of complex thing, but in fact it's actually time slicing. There's a lot of process here, and their burst time is different, so there's gonna be some kind of starvation problem. Starvation problem, right? But a round robin is basically means that, well, there's a starvation problem. Why don't we just slice the process of it and make sure that their time is doing it at the same time. So example, there's a P1 and P2 and P1 and P3 and P3 and P4 and P4, P4. And based on the time slicing, we don't have to think about this starvation problem because they're basically doing it at the same time. But the problem is that if there's like real time real time, this round robin is bad for the real time because there's no ordering. And this round robin is kind of important. Also, FCFS, SAF, they are also important. The round robin commonly used in the UI of the operating system, because if you look at the UI, it has to be instant and indefinite, whatever it takes longer. And round robin doing the time slicing because we have to make sure that this UI click is not making latency on other process. And that's gonna be the description of round robin and FCFS and SAF. So that's gonna be this is it. So I have a nice see you next time. Bye bye.